Hello, hi everyone. So today we will be discussing about end behavior of a polynomial. The end behavior of a polynomial is, what do you mean by an end behavior is, so if you graph all the x values and if you graph the corresponding y values, as x approaches infinity, where does the y approach to? Okay, that is essentially an end behavior. Okay, so all the polynomials, when as x approaches infinity or minus infinity, the y value will approach either positive infinity or negative infinity, and you need to determine where does the f of x approach. So that if you look at any polynomial function, it is of this or it is of this type. There are continuous functions, okay, and the end behavior is determined by this term, okay. So this is called the leading coefficient a0 and this is the degree. So whether the degree is odd or even, it has a bearing. Whether the leading coefficient is positive or negative, it has a bearing. So since end behavior is determined by leading coefficient and the degree, all the polynomials with leading coefficient, all the polynomials with odd degree and leading coefficient positive will have a particular type of end behavior. All the odd degree polynomials with a leading coefficient negative will have a particular type of end behavior. All the even degree polynomials with positive leading coefficient will have a specific end behavior, and all the even degree polynomials with negative leading coefficient will have a specific end behavior. Okay, so now to determine how does an odd degree polynomial with positive leading coefficient behaves, how does it behave, we will try to determine it using a function f of x equal to x plus 2. F of x equal to x plus 2, it is essentially an odd degree polynomial with leading coefficient to be positive, okay, and if you graph it, you have this line is f of x equal to x plus 2. As you can notice, as x approaches infinity, f of x also approaches infinity. Okay, this is a very large value. Consider this as a very large value. Similarly, as x approaches negative infinity, f of x also approaches negative infinity. As now, so that happens to be like the generalized end behavior of any odd degree polynomial. Okay, so any odd degree polynomial with leading coefficient positive, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Okay, now let us come to an odd degree polynomial with negative leading coefficient. All odd degree polynomials with negative leading coefficient will have a similar kind of behavior. Okay, so if you look at this, f of x is equals to minus, let us take h of x is equals to minus x plus 2. This is an odd degree polynomial with negative leading coefficient and it is a falling curve. Okay, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. So that is the end behavior of any odd degree polynomial with negative leading coefficient, say minus 3x cube plus 4x plus 1. Yeah, this is an odd degree polynomial with negative leading coefficient. This will have an end behavior like this. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. Whereas if I take f of x is equals to minus 3x cube, positive 3x cube plus 4x plus 1, it is now a odd degree polynomial with leading coefficient positive. So this has, as x approaches infinity, f of x approaches infinity, as x approaches negative infinity, f of x approaches negative infinity. Okay. Now we will have to look at the even degree polynomials, which we will do it now. Hi. So till now we discussed about how an odd function, an odd degree function behaves. Okay. We will now discuss how an even degree function with a positive leading coefficient behaves. Before going again, I reiterate that the end behavior is always determined by the first term, the term with the highest degree. All these other terms don't contribute to in determining the end behavior. Only the very first term. In the coefficient is called the leading coefficient and n is called the degree. So when the degree is even and the leading coefficient is positive, probably you can think that of a quadratic equation. You can simulate that to a quadratic equation. Here the difference is, as x approaches infinity, the f of x also approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. So that's what is mentioned here. And when x, if the leading coefficient is negative, as x approaches infinity, the f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. So the difference between odd and even is clear. The end behavior of an odd function is alternates. Okay, always. So it is on one side it is infinity, other side minus infinity. If on one side it is minus infinity, other side it is infinity. But the end behavior on both sides will be the same for an even function. If on both sides it will be either infinity or it will be negative infinity. The thing is, as leading coefficient is positive, as x approaches infinity, f of x approaches infinity in both the cases. If leading coefficient is negative, as x approaches infinity, f of x approaches negative infinity in both the cases. Okay, and it alternates in the case of odd function. In the case of even function, it remains the same. It remains the same as x approaches. And in case of even function, as x approaches infinity, negative infinity, it remains the same.